Now, in continuation with the previous three lectures, let us have the application of differentiation to the indeterminate forms. So let us see what is indeterminate form first. Okay, and let us apply the LHR, that is L Hospital rule, to that indeterminate forms. Okay, so let me ask you the question, what is indeterminate form? The value which cannot be determined. Okay, it is simply called indeterminate. Okay, so here you can see the word itself is reflecting what indeterminate. So if you read it separately, indeterminate. Okay, so indeterminate, so value which cannot be determined, then that value is called indeterminate form. Okay, 0 is determinate, 1 is determinate, infinity is determinate, but 0 by 0 is indeterminate. The reason I will tell you. Okay, 0 by 0, you know that 0 divided by anything. Okay, 0 divided by any constant, you know that it is equal to 0. And yes, constant divided by 0 is equal to infinity. So this is the way of recognizing what is the indeterminate form, whether it is indeterminate form or not. Okay, so 0 by 0, yes, it is indeterminate form. Why? Because if I replace here a equal to 0, you will get 0 by 0, and 0 by 0 by this rule is what coming out as 0, and 0 by 0 by this rule is coming out as infinity. So here you will you are observing that yes, 0 by 0 is having two values. The one value is 0 and the other value is infinity. So it is happening that a number is having two values, which is impossible, okay, in the algebra, and that's why this form, which is called 0 by 0 form, is called the indeterminate form. Okay, in similar way, infinity by infinity also is a indeterminate form. Infinity by infinity is also indeterminate form. How? You know that infinity divided by any constant. Okay, we know that if you divide infinity by any constant, what we get? We get infinity. But if you divide any constant by infinity, yes, we get 0. Okay, so see, if I replace in this a by infinity, and in this again a by infinity, yes, we get infinity by infinity, which is equal to infinity. And again here again, if I replace a by infinity, again this becomes infinity by infinity, which is 0. So here it is happening that what a number is having two values. Okay, infinity by infinity is infinity, and infinity by infinity is also equal to 0. So one number is, or one form is having two values, which is impossible, and that is why what we call it as indeterminate form. Okay, so 0 by 0 is indeterminate form, infinity by infinity is indeterminate form. Okay, then what is infinity raised to 0? This is also indeterminate form. How? You know that a raised to 0, what is a raised to 0? A raised to 0 is equal to 1. Agreed? And yes, infinity raised to a, what is infinity raised to a? So infinity raised to a is equal to infinity. So what that indicates, if I replace in this expression a by infinity, or in this expression if I replace what a by 0, yes, we get infinity raised to 0. Here again infinity raised to 0, and it has got two values, and that's why infinity raised to 0 is nothing but what indeterminate form. So with that way, yes, you can recognize various indeterminate forms. There are so many indeterminate forms, like 0 by 0, infinity by infinity, infinity minus infinity is also a indeterminate form, 0 into infinity is also indeterminate form. So all these are the what indeterminate forms. 1 raised to infinity is also indeterminate form. Yes, you can recognize. So 1 raised to infinity is 1, and anything raised to infinity is infinity. That's why it has got two values. Therefore, it is also indeterminate form. Okay, infinity raised to 0, just now I talked about, is also indeterminate form. So there are so many indeterminate forms. These two are called standard indeterminate forms, and these are the subcases of these two. Okay, and these are called the exponential indeterminate forms. Okay, now uh, how to deal with indeterminate form, how to make indeterminate forms determinate, that is our first and the main object of this lecture. So let us make indeterminate form a determinate form. Okay, so for that you will be requiring the help of your L'Hospital rule. What is L'Hospital rule? Suppose that there are two functions fx and gx, okay, which are differentiable functions or an open interval containing a, and then limit extends to a. Limit extends to a fx, suppose that it is equal to 0, and limit extends to a, g of x is also equal to 0, then yes, you will find that L is equal to, L is limit, L is equal to limit extends to a fx by gx. Here is fx, limit extends to fx is 0, and limit extends to a gx is also 0. So you will find that this is 0 by 0 form. So whenever you have 0 by 0 form, then you apply LHR. And what is LHR is saying? If you have this situation where we get 0 by 0 form, where we get this is 0 and this also is 0. So if you get a 0 by 0 form, then what you apply? You apply LHR. So this limit, which is limit extends to a, where we got 0 by 0 form for fx by gx as limit extends to a, then that will be equal to limit extends to a again. So limit extends to a again, differentiation of f and differentiation of g separately. Okay, if again same situation is continuing, that is you are getting 0 by 0 or infinity by infinity, again the differentiate. So derivative of f dash is f double dash and derivative of g dash is g double dash. If again you are coming out with the indeterminate form, again you continue same thing until we get a determinate form. Once we get determinate form, what we are through. Okay, so let us see this with the help of one example. So limit extends to 0, 1 minus cos x divided by x. Okay, now if you put x equal to 0 here, you know that cos 0 is equal to 1. Okay, 1 minus 1, numerator is 0, and if you put x is equal to 0, denominator also is equal to 0, and that is nothing but a 0 by 0 form, which is called which form? Indeterminate form. And you will find that limit extends to 0, yes, derivative of numerator, so d by dx of 1 minus cos x is what? Plus sin x. Derivative of 1 is 0 and derivative of minus cos x is plus sin x, minus minus plus sin x, and derivative of x with respect to x is 1. So if you put x is equal to 0 here, sin 0 is 1, which is sin 0 is 0, which is 0 divided by 1, and 0 divided by 1 is not indeterminate. 0 divided by 1 is, you know that it is equal to 0, it is determinate. That is your answer. So this limit extends to 0, 1 minus cos x divided by x was having a 0 by 0 form, that we have reduced it to a determinate form equal to 0. Second example can be given like this. So suppose that here you have limit extends to 0, extends to infinity, 3x plus 5 divided by 2x plus 1. Okay, you find that if you put x equal to infinity, 3 into infinity plus 5 is again infinity. Okay, 3 times infinity is infinity, plus infinity plus 5 is again infinity. You know that infinity is very large value. If you multiply a very large value by 3, again it is very large value. Okay, if you add to a very large value constant, again it is a very large value. Infinity is the largest value, so it is infinity by infinity form. And whenever we have infinity by infinity form or 0 by 0 form, in both the cases, yes, you can apply what? LHR. Okay, here this L'Hospital rule is applicable for 0 by 0, and in similar way LHR is also applicable for infinity by infinity form directly, because infinity by infinity form, yes, you can see that infinity by infinity form, okay, infinity by infinity, so you can see infinity divided by infinity can be written as 1 upon 0 and divided by 1 upon 0. You know that denominator of denominator is numerator, and numerator's denominator is denominator, so we get what? 0 by 0 form. So every infinity by infinity form can be reduced to very easily a 0 by 0 form, and that's why as we can apply your LHR to 0 by 0 form, we can also apply LHR to infinity by infinity form also. Okay, so what we get? Limit extends to infinity, 3x plus 5 divided by 2x plus 1, it is what? Infinity by infinity form, therefore we can directly apply LHR. Okay, so if you apply LHR, yes, you need to differentiate. Derivative of 3x plus 5 is 3, okay, and derivative of 2x plus 1 is equal to what? 2. Okay, and if you put x equal to infinity, no x term is there, therefore that will become what? 0. Okay, so the answer is 3 by 2 plus 0, which is equal to 3 by 2. Okay, so I think there is a printing mistake over here. So x is taken common from numerator. There is other way of finding its limit also. If x tends to infinity, we create a 1 by x term, so that if you put x equal to infinity, 1 upon infinity becomes 0 and that term vanishes. So here you can see that if I take x common from numerator and x common from denominator, that x will get cancelled. And if that x gets cancelled, yes, you have what, 3 divided by 2 plus 5 by x and 1 by x. And if x is infinity, 5 by x, that is 5 by infinity is 0, and 1 by x, that is also 0. So we have simply the answer equal to 3 by 2. So by both the ways, by direct way and by LHR, we get the answer equal to 3 by 2.